Okay, 77. Where are we time-wise? I think it started a new video, a new recording, yeah. Oh, I thought I was at 12 minutes and how the time flies. 77. These are difficult concepts in the quantum mechanical world. See if I've got some more tea. I think it's all there. No more tea. There's only 3 more pages to go, but let's just have a look again what I've learned up to now. Particle and wave, and both particle and wave until observed. And that's what is happening in the quantum world. It's got both that features. Like a photon can, it's both a particle and a wave until you force it to choose between the one or the other, or by designing an experiment asking, are you a particle? And it says, yes, I'm a particle. Say, are you a wave? Say, yes, I'm a wave. Delayed choice experiment. What is that about again? That brings out that concept. I'll have to look again at this delayed choice experiment. I got it when I was reading it, but now my memory can't bring it up. So I'll have to look at it again. That's a difficult one. Local realism, particle or wave, collapses upon observation, goes into a definitive state. Particle, concentrated wave, spread out. Quantum unit, experiment, particle, wave. Delayed choice experiment. 76. Let's finish the last 3 pages. 77. Wigner's friend. Macroscopic objects. Mix the supreme collapses only after observation is made. So quantum mechanics violates local realism. Local realism can be reintroduced in quantum mechanics if there are hidden variables present. That is what I said, missing information. Missing information can clear it up, change your thought on the process. De Broglie proposed that matter waves and particles were not incompatible description because the matter waves, called pilot waves, were the signature of an underlying theory which details we have yet to discover and that provide the missing parameters to make the description fully. To see how this works, we have to use particles in entangled, superimposed quantum states. So entangled particles can clear this up. Rosen, Podolsky, EPR experiment, Einstein. superimposed state when a particle and its antiparticle combine, two resulting photons must have exactly opposite polarization. Leave the site of annihilation. EPR experiment. What are we dealing here with? Local realism. Pilot waves. EPR. What is this experiment about? Two photons, polarization. If one observer takes the polarization of his photon, okay. Two photons. Polarization up and down. One is in the up polarization, the other one is in the down polarization. If one observer detects the polarization, I see what they're doing here. Okay. To be down, that separation between the observers. So the chances that they are observing at exactly the same time, what is happening then? We can make the separation so large that the light signal doesn't have time to travel between the observers to guarantee that the other photon is opposite. Since information can travel faster than light, we are left with two photons, which is called an entanglement state, macroscopic distances. Single quantum state. So that information apparently travels faster than light, which is not also, or the description of the state of each photon carries more hidden information about measurement. I think, how can we possibly decide which is which? So this experiment they're using to hidden information. Use this experiment to determine is there hidden information. I don't really understand how this clears it up, this hidden information story. Can it be cleared up? Local realism, is that how things are in the quantum world? Local realism can be reintroduced into quantum mechanics. What does local realism say? It says that it does have a specific property. It's either if it's not observed or detected, it is in a specific state. And with this experiment they want to see, is that the case? Is it in a definite state when it's not observed? Entangled, large distance between the observers. So they want to clear up if local realism is present in the quantum world. Stewart Bell proved that the second interpretation that quantum mechanics was incomplete was also incorrect. Proof that the second interpretation, that quantum mechanics was incomplete, was also incorrect. I get very confused when there's two negatives. No physical theory of local hidden variables can ever reproduce all of the predictions of quantum mechanics. So they accept that it's all the quantum states are present. It's in a state of superposition. There's no definite state. This is what this comes to. J is Bell. Proved. Quantum superposition state is real. I think that's what it says. Uh, 78. There, that's the end of it. Test of this theorem was ingeniously developed. Test of this theorem. It predicted polarization of entangled photons, assuming the quantum mechanics non-local realism is true. He developed a mathematical quantity called S. Total measurement spin of the two particles in the experiment. It is in an inequality modulus of S or whatever would be strictly obeyed if there were indeed hidden variables, but would be violated if quantum mechanics was strictly obeyed. Series of experiments increase sophistication to test where Bell's inequalities are satisfied. 2015 conclusive tests were published by B. Henson and Nadelfi. He claimed that S is bigger than 2. And then statistics, quantum optics, and quantum information. 11p result. But bottom line is that any hidden variables theory to correct quantum mechanics for incompleteness and to introduce the Broglie pilot wave idea is ruled out by these experiments to at least the 11's phi delta level. The measure occurring about one time in more than 1 trillion measurements. So these experiments showed that quantum mechanics don't have hidden variables, and local realism is not how the quantum world operates. Experiments proved. Quantum world, not local realism. Present. State of superposition. Last page. Where are my timelines? 14 minutes. Simple theorem. Simple theorem. A test whether quantum theory can be repaired by invoking a larger theory that provides missing information. A simple theorem that tests whether quantum theory can be repaired by invoking a larger theory that provides missing information. Is there something happening that we don't know about? I think that's what it is talking about. And he proposed, he had a simple statement, this one, modulus is whatever is less than 2.0. The total measurement of spin of the two particles. This test involved in inequality, which we strictly obeyed if there were indeed hidden variables. So the measurements must be less, some quantity measured, I think, must be less than 2 if there were hidden variables. And the tests went above 2. Well, that doesn't sound like much, but anyway. The conclusion from this test is that particles and observers can remain in complex, entangled states that prevent observers from experiencing a common reality. Prevent observers from experiencing common reality, and that quantum systems do not have fixed properties. So if you don't watch the news, maybe the war is not going on and people are not dying. I don't watch the news. All those terrible things. Maybe the people are then alive in another reality. Do not have fixed properties until the moment of observation. So after I summarize that, this behavior is not caused by quantum being an incomplete theory that needs to be patched up with superior theory that can provide missing information. The choice of quantum posed by the experiment at the instant of interaction of the detector or your wave of particle determines the property of the particle, independent of the paths taken by the particle. Quantum superposition is real. I think that's the question I started out with when I started this chapter. The Copenhagen interpretation. Does it really say that all states are present? Or is it just the mathematical theory that says, and all this is saying no? It's real in the real world. Quantum superposition is real. So it's both a particle and a wave until you observe it. Or this, well, what this say is actually more. There's no common reality. Observers from a spinner. No common reality. No common. Whoa, what on earth does that mean? No common reality. One have to think about these things. Okay, but that is this chapter.